Alright, so in this video we're going to look at how to draw a free body diagram for the friction virtual lab using Google Docs. So we've got some data that we've collected, and we have the wooden block on the table at 100 grams, the frictional force static, the frictional force kinetic, the wood block on lab table at 754 grams. So if we were to do this by hand, you'd have to draw yourself 4 free body diagrams with 4 sets of calculations. So I'm going to show you how you can maybe streamline it a little bit by doing a free body diagram in Google Docs. So we're going to go to Insert, Drawing, New One, and here's where we're going to build our free body diagram. So we're going to start off with just a horizontal line. This is going to be our tabletop. Let's put a box. This can represent our block that we pulled. It always seems to fill it in, so we'll just go to transparent. Now we're going to add in the mass, so we can put in a text box. So for the first one it was 100 grams. We'll put that in kilograms, 0.100 kgs. Can always move it over to center it. Even make the font a little bit larger, just so it shows up. Okay, let's put in our forces. We're going to have gravity down. It's a little bit of a thin line, so we can make it thicker. We have the normal force going up. Try to make these two vectors about the same length. We have our applied force, and we have our frictional force, which was in the opposite direction. And try to make these two vectors look as close as you can to being the same length. Okay, so now we need to actually add in our forces. So we're going to use a text box. So I'm going to go force of gravity, and we'll make this a subscript, equals, and we'll show the calculation for the first one, 0.100 kilograms, 9.8 newtons per meter. You can actually copy and paste this. Don't have to type it out again. And that would give us 0.98 newtons. Now, we know that the normal force has to be equal to gravity. So I've already done that calculation. I'll move it here. Now, instead of this being F subscript G, it's going to be capital N. Our applied force, so F applied, was equal to, and from our chart, 0.79 newtons. I'm just going to turn that into a subscript. And actually, I'm just going to copy this and repaste it. Always makes this huge box, so you just kind of reduce the box a bit. I'm going to move this down here. And when we had an applied force of 0.79 newtons, that was equivalent to our static friction force. So we have gravity, normal, applied force, frictional force. Let's go save and close. Okay, so we've inserted it. This was actually for the static friction part of the lab. Now what I need to do is copy this. Let's move down to the next page, and now we need to do a second free body diagram for one was kinetic friction. So I'm just going to paste. Now these are obviously not the same numbers. If we go back up, static friction was 0.79 newtons. Kinetic friction was 0.75, so we need to go down to our free body diagram and augment that. Double click, I go in, so this is now going to be 7.5, and for my frictional force, this is 7.5, and I'm just going to go into the subscript and make that a K. Otherwise, everything else is the same. So this is now my kinetic friction. So now let's make our free body diagrams when the wood block was 754 grams. Static friction was 5.8, kinetic friction was 4.0. So I'm just going to copy this free body diagram. I'll scroll down. I've got a header ready to go. Paste it. I've already got the title. double click, and let's go in and do the quick edit. So the mass is 754. I can go down here, 754. This ends up being 7.39 when we round it. Okay, so gravity is going to be 7.39 newtons down. Obviously the normal is going to be 7.39 newtons up. So you know from our chart the applied force for friction was 5.8 newtons when it was static. So 5.8 newtons applied. Frictional force 5.8 newtons. Close. We can copy and paste this. And we can also copy and paste the title. So we can copy and paste the title. This is now going to be for kinetic friction. Okay, and let's go in and make sure that we have the right numbers for the applied force. Go back up to the chart. So for the applied force for kinetic friction was 4 newtons. So this is 4.0. This is 4.0. Make sure that we change our subscript. This is kinetic friction, and close. So once you have your first free body diagram, it's very quick and easy to make the next ones. Okay, and once you've done your free body diagrams, if you want to fit them a little bit nicely onto the page, I would say not make them much smaller than this. You should be able to get 2 free body diagrams per page. Just be careful, make sure that you have proper labeling, especially for things like the applied force and which of the frictions it is. So just be careful, because when people copy and paste, sometimes they don't pay attention to the small details.